Problem statement. A half-cylinder log is in static equilibrium, as shown in the figure below. The log has a length of 6 meters and a radius of 0.6 meters. It is partly submerged in water and oil as depicted below. Determine the following: the total horizontal force on the half-cylinder by the water and oil, and the total vertical force exerted on the half-cylinder by the water and oil. Um, Part A of the problem tells us what is the total force, total horizontal force of the oil and water. So the force of the oil comes because of we have a triangular distribution here of the oil, and then the water is feeling this pressure, and on top of this, we have the distribution the of the water. Right? This is the 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 water, and this is the oil, and this is the pressure um, due to the oil. So the water is feeling that pressure on top of it, right? Okay. So to determine the horizontal force, there are several methods. One way is we can get this area of the triangle and multiply by the length of 6 meters to get the force of the oil. So first we have to get this pressure here. This pressure, I'm going to call example pressure 1. And pressure 1 will be equal to what? Gamma of oil times the height. And the height is the radius, which is 0.6. So gamma of oil will be 0.8, which is the value of S, times 9,800, 800 or 810. We can use example here, 810, times 0.6, and P1 will give us a value of 4.709 kilopascals. That will be the pressure in one. And of course, also we can get also this total pressure here in two. This pressure here, the total pressure at the bottom here at this point. So the pressure in two, we can call this pressure in two, and the pressure in two will be equal to the pressure in one, which is the rectangle here, the pressure in one, plus the pressure due to the water, right? So that's going to be gamma of water times 0.6. If we plug values, pressure in 2 will be equal to 10.595 kilopascals. Okay, so then the horizontal force due to the oil will be FH oil will be equal to what? It will be it will be P1, right? Will be P1 at the bottom times the height, and the height is 0.6 divided by 2. That's the area of the triangle, times the length. The length is 6 meters. Therefore, the force of the oil, horizontal force of the oil, will be equal to 8.46 kilonewtons. Okay. What about the force, the horizontal force due to the water? So let's do now the horizontal force due to the water, which is going to be all of this. Let me write down here. Going to be the area of this trapezoid, right, times the length. So the area of the trapezoid is the top, which is P1, the bottom, which is P2, divided by 2, uh, times the height, which is 0.6, and times the length, which is 6. If we plug values, we know P1 and P2. This will give us a value of 27.0 55 kilonewtons. Therefore, the total horizontal force will be equal to 8.46 plus 27.55, and this will give me a value of 36.01 kilonewtons. Okay, now let's get the vertical force, because that's the part B of the question, right? So the part B is um, what is the total vertical force? Okay, so in the vertical force, we go back here to the figure. The vertical force, we can divide this also into two parts. We have uh, here, the vertical force acting on this surface, and that will be due to the weight of the oil, which is this. And then we have also the vertical force acting on this part of the curve, on the lower part of the curve here. And that will be equal to, so to kind of find out where that vertical force is coming from. So the pressure here in this part of the curve would be the same. So if we fill with the same liquids here, the pressure, if we fill this side, if we fill this side with the same liquids as on the left, the pressure on this side and on this side will be the same, right? Because it's the same height. Example here, the pressure here and here at the same height, if I fill on the right, if I fill here with the same liquids as the left, the pressure will be the same. Which means that the the force, the vertical force acting on this curve is equivalent as having the liquids on top of on top of this vertical on top of this curve right here. Okay, then we can say then the vertical force on the oil is the vertical force on the oil is this, and the vertical force on the water is all of this is the all the weight acting above this. So if you realize that the vertical force of the water involves everything up to here, involves this, okay? And that will be, of course, up. And the vertical force on the oil is this little piece here, acting down. If you subtract all of this minus this little piece, basically you have only the cylindrical log. Only you have this. So then the vertical force will be equal to the weight of water acting on this, right? Because that's where the vertical force is coming from, plus the plus the weight of the oil on this area, only on this area, the weight of the oil on this area. And the reason is because when I am subtracting the whole thing minus this, I'm getting only half of the, or one quarter of the log. Therefore, the vertical force will be equal to what? It will be equal to gamma times volume, because that's the weight. Weight is equal gamma times volume. So vertical force total will be equal to gamma of water, gamma of water, and one quarter of that, one quarter of the volume of the logs, which is going to be one quarter of pi times radius squared times the length, right? That will be plus gamma of oil, also the same, right? The same volume, one quarter pi radius squared times L. So this volume is equal to 1.697 cubic meters, And this is because we have a 1/4 times pi. Radius is 0.6 square and times the length. So all of this gives me that. And then I can simply here do the following. Then the vertical force total will be equal to 9,810 times 1.697 plus gamma of oil will be 0.8 times 9,810 times 1.697. And this will give me a value of the vertical force of 29.95 kilonewtons, right? Of course, the vertical force will be acting upwards, and the horizontal force will be acting to the right, which is going to be here. Okay, and those will be the answer of the problem.